Hi, I'm Andy Barnes from the team at UQ, and I'm here on behalf of our collaborators at WorldFish and Wilderlab to tell you about disease diagnosis in a fish farmer's backpack. According to the United Nations, food and nutrition security is achieved if adequate food in terms of quantity and quality is accessible for and utilised by all individuals at all times to live a happy and healthy life. Fish is a particularly good source of high quality, well utilised protein, but it's also high in iron, vitamin A and iodine that are critical in childhood development and are deficient in many staple foods. As fisheries are mostly fish to capacity, the increasing demand for fish is being met by aquaculture, one of the fastest growing food production sectors. Indeed, 54.1 million tonnes of finfish were produced by aquaculture in 2018, generating over $138 billion and employing 19 million people directly in finfish aquaculture production, the majority of these in developing countries. Disease is the major constraint to aquaculture growth and is a current focus of the FAO subcommittee on aquaculture. In most developing countries, mitigation of disease includes stocking more fish to offset the losses, which makes the problem worse, and antibiotic treatments that lead to antimicrobial resistance. This underlines the importance of including aquaculture in a One Health approach to antibiotic stewardship. Evidence-based disease control is central to reducing antibiotic use. We have all seen the power of genomic sequencing in outbreak management during the current COVID pandemic. Such high-resolution information identifies routes of transmission for biosecurity, informs appropriate treatments, and tells us which strains to include in vaccines. While genomic sequencing costs have fallen dramatically over the last decade, sample preparation is costly and involves toxic chemicals, and next-generation sequencers are expensive, require large-scale infrastructure, and the masses of sequencing data need to be analysed to obtain actionable information. This puts the power of genomic sequencing beyond the reach of smallholder farmers in developing nations. Lab in a Backpack creates a low-cost sample processing and genomic sequencing workflow that can be conducted anywhere, and it doesn't require expensive equipment, reagents, or generate any toxic waste. Shupra is extracting DNA from samples swabbed from sick fish. Our first innovation is a low-cost DNA purification workflow based on a safe household detergent available anywhere in the world. The samples have DNA tags or barcodes added, are pooled with samples collected during the same trip, and then loaded onto a MinION Nanopore sequencer. These pocket-sized devices are cheap to buy, simple to operate, and don't require lab facilities. Even at UQ, we do our Nanopore sequencing in the office, not the lab. But the data they generate are fuzzy. It's not possible to get actionable information directly from raw instrument reads. Our next innovation adds cloud-based machine learning from partners Wilderlab, trained on a custom fish pathogen database developed by UQ and WorldFish. Here we see the alpha version of the app running on an Android phone. The first few reads from the Nanopore instrument are uploaded and return a detailed, accurate diagnosis in a few seconds. A simple user interface then provides accurate information in near real time via any laptop or smartphone, enabling the local fisheries officers to advise the farmers, and for simple custom vaccines to be manufactured using local fermentation capability. They can be used to vaccinate new stock on the farms that have the same bacterial strain types, thereby securing the output of the next crop, preventing spread between farms, and removing the need for antibiotics. These big data-driven but locally implemented solutions align with the FAO's recently proposed progressive management pathway for improving aquaculture biosecurity. Lab in a Backpack can provide information that is accessible in real time and employed directly in biosecurity risk definition, systems implementation, preparedness, and of course sustainable health management through vaccination. This will deliver real advances in local economy, nutrition security, human health, and animal welfare. Thank you for the invitation, thanks for listening, and thanks to our partners in the Inspire Challenge 2019 prize, which has built a workflow to put the power of genomic diagnostics in a fish farmer's backpack.